Hi guys, it seems like some of you have questions about number 8, so I'm just going to go over this question with you guys. For number 6, it was kind of the first half of this question. Number 6, you found where this function was decreasing. So now we're just going to try to find out where it is increasing and concave up. If you want to know where a function's increasing, then you need to find where its derivative is positive. Concave up, you need to find where its second derivative is positive. So for the derivative of this, you need to first use the product rule to do that. So first times the derivative of the second second times the derivative of the first. Now we're going to clean this up a bit. So this x is in the numerator, 2 is in the denominator, and that negative exponent will cause this to go down here. Now, here we need to find a common denominator between these two. It'll make it easier to find the zeros of this equation. So I'm going to multiply by this denominator. So now the new denominator will be this. And this part, the square roots will cancel out when you multiply that. So it'll be 2 times x plus 3. So if you simplify this, x plus 2x plus 6. Now we need to know where this thing equals 0 and where this thing doesn't exist. So it equals 0 at x equals negative 2. So that'll be on your number line. And then the bottom will not exist at negative 3 and also anywhere to the left of negative 3. If you look at the domain of this original function, you can't have any values that are less than negative 3 in it. So my number line is just going to stop there. Now we're just going to test values into the number line to see where this derivative is positive or negative. So let's plug in like negative 2.5. So 3 times negative 2.5 is more than 6, so this will end up being negative. The bottom's always positive, so that'll be negative. Here, if I plug in a number like 0, the top will be positive, the bottom will be positive. So this is decreasing and then increasing. So for number 6, it was looking for this interval. So that's kind of this whole work was kind of like number 6. And then you kind of picked up here for number 8. So I'm just going to put this one here now. So we need to find the second derivative now. It'll be easier to do with this simplified form. So now if we need the second derivative, then we're going to need the quotient rule to do that. So that'll be bottom times the derivative of the top, which is just 3, minus top, make sure you use parentheses, times the derivative of the bottom. So when you take this power of 1/2 down to multiply by the 2, those will undo, and it'll just be x plus 3 to the negative 1/2 times the derivative of the inside, but that's just 1, all over the bottom squared. So that'll be 4 times x plus 3. So let's clean this up a bit. So I have 6. This is a little fraction here because this has a negative exponent. So 3x plus 6 over the square root of x plus 3, and that's all over 4 times x plus 3. So now this is kind of annoying because we have fractions within fractions. So I'm going to multiply by something that'll clear these fractions out. If I multiply the numerator by root x plus 3 and the denominator by that, then that'll clear this fraction here because that's what's in the denominator. So this times this whole part will just be 6 times x plus 3. Then this times this fraction, those square roots will cancel and I'll just be left with minus 3x. I'll distribute the negative to be minus 6. And that's all over 4. Now if I multiply these two together, this power is 1, this power is 1/2. So it'll be x plus 3 to the 3/2. If I simplify this here, I have 6x minus 3x, it's 3x. 18 minus 6 is plus 12. So the only critical points at the second derivative here. The numerator, -4, makes that 0. However, that's not in the domain of your function anyway, so you can ignore it. So then my number line for this one will just be -3. So you can just test any value in this region into the second derivative to determine whether it's positive or negative. I'm going to plug in 0. That'll make the numerator positive. The bottom's always positive. So this thing's always concave up. So if you look for where it's both increasing and concave up, that's happening on the interval from -2 to infinity. I'll send a separate video for the other questions.